Hey guys, welcome to a level 3 differentiation exam for level 3 calculus. So some people have been asking me to get into level 3 maths. Well, whoever's watching, I hope you enjoy the video. All right, question 1: differentiate y equals to 5 cos of 3x. All right, so in this question, okay, we need to use the chain rule. Okay, so the chain rule states that we need to not multiply. We need to differentiate the outer function and multiply that with the derivative of the inner function, and then we multiply it by the inner function. Okay, so what I mean here is we're gonna differentiate this one piece at a time. So we have five cos. Okay, that's the outer function, and we're gonna differentiate that. That becomes 5 sine. Oh wait, no, it does not become 5 sine. It becomes negative sine. Sorry, it becomes 5 negative 5 sine. Okay, and if we differentiate our 3x, which is our inner function, that becomes just 3. So but we also need to multiply this one by our so right now we have negative 5 sine multiplied by 3, but we also need to multiply by our inner function again. So we need to multiply this by 3x. Alright, so what you're going to get now is it's going to become, so negative 5 sine times 3, that's negative 15 sine. And then times 3x, so simply just going to add the 3x. So dy over dx equals to negative 15 sine of 3x. And getting this differentiation correct will get you an achieved grade there. Alright, find the gradient of the normal to a function y equals to 3x squared minus 5x whole squared at the point 1, 4. Alright, so what it means by the normal is it's similar to the tangent line, but it's not exactly the tangent line. Okay, the normal line is cuts the tangent line perpendicular. Okay, so what I mean here, I'm going to give you an example. Okay, so if I have for example, a parabola here, for example, I'm going to draw my tangent line. Let's just say I'm going to draw it here. My normal line will cut the tangent line perpendicular. So if this is our tangent, if this first line I draw here is our tangent, then our normal line will just simply cut perpendicular to our tangent line. So that will be our normal. Okay. So how if we get the gradient at a tangent point, so if we get the gradient at a tangent, all we have to do to find the normal is what am I saying? All we have to do is sorry guys. All we have to do is sorry guys, just hold up. Getting a mind blank. All right, sorry. So, sorry about that. So, I've refreshed now. So, to change from the tangent to a normal, all you have to do is divide by -1 and then inverse it. So find the inverse of the. So first you divide by -1 and then you find the inverse. Okay. But in order to find the gradient of our tangent line first at the point 1, 4, we do need to differentiate our function first. Okay. So as you can see here, okay, once again, we're going to use the chain rule, okay? So that's our that's the derivative of our inner function multiplied by the derivative of our outer function, and then multiplied by the inner function, okay? So what I'm saying is here, so I'm gonna differentiate the outer function, okay? So this becomes 3x squared minus 5x. Move this power down by 1. Move the power down by 1, so the 2 becomes a 1. So it just becomes power of 1. So dy over dx equals 2. And we also need to multiply by the derivative of the inner function. The inner function is that's the function that's inside the brackets. So 3x squared minus 5x, the derivative of 3x squared minus 5x is 6x minus 5. So that's our derivative, okay? So now we need to find the gradient at the normal, but first we need to find the gradient at the tangent at the point of 1, 4. So we're going to substitute x equals to 1. So dy equals dy over dx equals to 2, 3 bracket 1 squared minus 5. Oh, sorry. Bracket 1 squared, sorry, minus 5 to the power of 1. Or we can just ignore that. Power of 1 is just multiplied by 6 minus 5. Alright, so dy over dx equals to 2 negative 2 multiplied by 1. So therefore, our gradient would be will come out to be as negative 4. But that's our gradient of our that's the gradient of our tangent line. We need to find the gradient of the normal line, and all we have to do is first we divide by negative 1. Okay, sorry, so first we divide by negative 1, and that equals to 4, and then we find the inverse of that. Okay, so we need to find the inverse of 4, and that becomes 1 over 4. So your final answer for this question is that the gradient of the normal line is 1 over 4, but the gradient of the tangent line is negative 4. So the final answer you need to write down here. You need to make specifically sure that your final answer is 1 over 4. And again, this is just an achieved question there. Hey guys, welcome back to the video. Sorry, the last one got cut off. Screen recorder decided to cut off midway. So I'm going to get back to where I left off, which is part C. So I'm going to get straight back into it. So if x equals to 2 sine t and y equals to cos 2t, show that dy over dx equals to negative 2 sine t. Alright, for this question, okay, we're given x in terms of one variable, which is t, and y in terms of a variable, which is the same variable as what x was given in, which is also t, and we're asked to find what dy over dx is. In order to do this, we need to use the parametric functions, okay? So we have to use we need to find dx over dt and dy over dt, and we need to cross multiply the two dt's together in order to get rid of the dt, and then we'll get our dy over dx is, okay? So our step 1 is to find what dx over dt is and dy over dt. We'll start with dx over dt. So if we have here dx over dt equals to, that simply sine differentiates to cos, so that becomes 2 cos of t. Dy over dt, that equals to cos differentiates to negative sine, okay, and you move to then you differentiate 2t, which is our inner function, okay, differentiate 2t, that will give us 2, so you move the 2 to the front, that becomes 2 cos, sorry, not 2 cos, cos differentiates to negative sine, so it becomes 2 negative sine of 2t. If we rewrite this, it's a bit ugly, so dy over dx, not dy, what am I doing? So dy over dt equals to negative 2 sine of 2t. Alright, so now we need now we have dx over dt and dy over dt. We need to find dy over dx, okay? The only way to do this is by cross multiplying the two dt's, and cross multiply the two dt's in order to get rid of it, cancel each other out, and then we'll be left with dy over dx. So dy over dx, okay, notice that both dt's are at the denominator, and if we multiply right now, we are not able to get rid of the dt because they're both on the denominator. That means we need to move one of these functions to the numerator, move one of the dt's to the numerator in order to have the cross multiplication to remove the dt. So you ask, which one do I inverse? Is it dx over dt or dy over dt? Alright, so let's pretend we inverse dy over dt. So if we inverse dy over dt, it will become dt over dy. And if we keep dx over dt the same, this is what you're going to be left with. So dt cancel with dt, but notice that the dx is going to move in the position of the cancelled dt. So you'll get dx over dy, but we're looking for dy over dx, okay? And that makes things a lot more complicated. So what you really need to do is you need to inverse dx over dt to make dt over dx, and you want to multiply that by dy over dt. In this case, the two dt's will cancel out, and then the dy will move in place of the cancelled dt, and this time you'll get what you need, which is dy over dx, okay? So how we're going to inverse is simply, we're just going to flip both sides of the equation. So if we flip one side of the equation, we have to flip the other side of the equation as well. So dx over dt over dx, and we need to inverse 2 cos of t, and that just simply becomes 1 divided by 2 cos of t, okay? So we have our dx over dt, and we have our dy over dt. We just need to multiply these two together to get our dy over dx. So dy over dx is equal to 1 over 2 cos t multiplied by negative 2 sine of 2t. That's over 1. So dy over dx is equal to negative 2 sine of 2t over 2 cos t. Alright, so now we need to prove that it's equal to negative 2 sine of t. One thing we do know is that sine of 2t can be rewritten as 2 sine t cos t, okay? We can rewrite sine of 2t. So we can rewrite this part of the equation, okay? We can rewrite that as 2 sine t cos t, okay? So simply we're going to replace sine 2t with 2 sine t cos t, okay? So our new dy over dx will become negative 2 times of 2, the 2 at the front, so times of 2 sine t cos t. And then we're going to keep the denominator the same, so 2 cos of t. Notice that we have cos t on the numerator and the denominator. So cos t can cancel each other out, so cos t cancels with cos t. So what we're left with is dy over dx equals to negative 4 of sine t divided by 2. And if we simplify this, just negative 4 divided by 2, that becomes negative 2 sine t. And that is what the question originally had. So that's your final answer there with all the working. And this question is a merit question, okay? So getting a merit question is the correct solution. And to get an achieved, it's the correct expressions for dx over dt and dy over dt. So you need both of these, dx over dt and dy over dt, and you'll get an achieved. Alright, moving along. Find the x value at which the tangent of a function y equals to 4 divided by e to the power of 2x minus 2 plus 8x is parallel to the x-axis. Alright, so this question, okay, it asks you to find the when it's parallel to the x-axis, okay, which means that, for example, if a line is parallel to the x-axis, that also means that the gradient of the line is 0. Okay, since the line is horizontal, it's not increasing, so therefore it's just staying as a flat surface, and therefore the gradient is actually 0. So basically what you want to do here, so because it has, we need to differentiate to find our dy over dx, and then we need to make the gradient 0 to find the x value at where the tangent is parallel to the x-axis. Alright, so in this question we have 4 divided by e to the power of 2x minus 2. So in order to differentiate, so last year in level 2, you had if you had fractions, or for example, it would just be 4 divided by x, which means you can move the x back up. So for example, last year you would have, for example, a question like this, so 4 divided by x, which means that you could move the x back up, and that will become y equals to 4 to the power of x, 4 times x to the power of negative 1. But in this case, you actually cannot, you can't move e to the power of 2x minus 2 up like you did with the x. So that means we need to use our quotient rule, okay? So our quotient rule states that we're just going to call this the numerator and denominator, so that the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator, and you divide that by the denominator squared, okay? So if we're going to put this into practice, okay, so that's basically we're going to say dy, that's ugly, dy over dx is equal to, so so first thing to do is numerator multiplied by the numerator, what am I saying? So denominator multiplied by the derivative of the numerator, okay? So that becomes e to the power of 2x minus 2 multiplied by the derivative of 4. The derivative of 4 is actually 0, so that just becomes multiplied by 0, and minus the numerator multiplied by the derivative of the denominator. So that becomes minus 4 times of the derivative of e to the power of 2x minus 2. Now, e is a very special number, okay? Which means that when you actually differentiate it, it's not simply your rule. It's not the rule that you multiply the power with the front number and then you take power down by 1. It doesn't work like that. So basically, you need to differentiate the power, and then you move the power to the front, but the power remains the same. So once again, you differentiate the power, you take that derivative of the power and move it to the front. However, the power remains the same. Okay. So what I'm saying is, so the power is 2x minus 2. The derivative of 2x minus 2 is just simply 2. Okay. So what's going to happen here is that the 2 is going to come to the front, so it's going to become 2e, and the power is going to become this. Is going to stay the same. So that's going to be to the power of 2x minus 2. Alright, so that's going to be our answer, and we're going to divide that by e to the power of 2x minus 2 whole squared, okay? And that is our dy over dx. So anything multiplied by 0 is still 0, so we can just get rid of that. That doesn't really exist. So all we have here is dy over dx equals to negative 4 of, that can simplify to negative 8. That simplifies to negative 8e to the power of 2x minus 2 divided by e to the power of 2x minus 2 whole squared. Okay, since it's parallel to the x-axis, like I said before, that means the gradient is 0. So simply we're going to substitute the gradient equals to 0. So 0 equals to negative 8e to the power of 2x minus 2 divided by e to the power of 2x minus 2 whole squared. Alright, so we're going to move the e to the power of 2x minus 2 whole squared to the other side of the equation. But you know that 0 times of anything is still 0. So that means if I move this to the other side, it will still be 0 equals to negative 8e to the power of 2x minus 2. And that's because, like I said, anything multiplied by 0 is still 0. Sorry, something wrong with my eye. Oh yeah, something I just totally forgot. It was the plus 8x at the end there, so sorry, we just... 8x differentiates to 8. Okay, that's pretty straightforward. Sorry about that, guys. I was like, oh, I'm missing something. Yeah, I'm missing the plus 8x, which differentiates to 8. So we need to add that one in. Sorry about that, guys. That's a bit stupid on my part. So that means that's actually wrong. E to the power of 2x minus 2 whole squared. Sorry. E to the power of 2x minus 2 whole squared. Alright, so that's so the first thing I actually have to do is we need to move the plus 8 to the other side. That becomes negative 8 is equal to negative 8e to the power of 2x minus 2 divided by e to the power of 2x minus 2 whole squared. Now if we move it back, it will be a different story. So becomes negative 8 times of e to the power of 2x minus 2 whole squared. And that is equal to negative 8e to the power of 2x minus 2. Notice that there's 2 to the power of 2x, there's e to the power of 2x minus 2 on both sides. So this can cancel with this, and the power can go down by 1. So that just simply becomes negative 8 times e to the power of 2x minus 2 to the power of 1 equals to negative 8. So therefore, e to the power of 2x minus 2 is equal to 1. Okay? So, you know that anything to the power of 0... Sorry, what am I saying? So anything to the power of 0 is 1. So for example, e to the power of 0 is 1. So therefore, we know that 2x minus 2 equals to 0. And therefore, our x value is actually equal to 1. And if you get your x value equal to 1 there, you'll get your merit grade. To get an achieved grade, you're looking for a correct expression for dy over dx. So getting this correct here will get you an achieved. Yeah, guys, sorry about missing the 8x there, because I wasn't really paying attention to the question. That's my fault for missing the plus 8x at the end. Hey guys, welcome back. Sorry that the video got cut off again due to screen recording, so I had to rewind a little bit, and then we're just going to continue back from where we left off. Sorry about that. So what is the maximum volume of a cone if the slant length of the cone is 20 centimeters? Okay, so in this case, okay, you need to find the volume of a cone. So the first thing you need to do is go to your formula sheet and find the equation for the volume of a cone. You should find that V equals to 1/3 of pi r squared h. So the natural thing tells you to find the maximum volume, so you think you have to find the derivative. However, you have two unknown variables, which means you can't actually find the derivative. You need to find one variable in terms of the other, and then replace that variable inside the volume formula, and then find the derivative. So if I drew a line down the cone, that would be the height of the cone equal to h. So then we realize we have a right angle triangle, so we can apply right angle triangle rules. So we can say that r squared plus h squared equals to 20 squared. 20 squared is 400. I'm going to write h in terms of r, and then replace h in the equation with my result. The reason of that is because there's only one h in the equation, which means it's a lot easier. Because it's r squared, if I did r in terms of h, then it'd be a lot harder, because I would have to square that result as well. So that's a lot more working. So I'm gonna say that h squared equals to 400 minus r squared. Therefore, h equals to square root of 400 minus r squared. I'm gonna plug that back into our equation. So v equals to 1/3 pi r squared multiplied by square root of 400 minus r squared. Alright, so now we can find our derivative, dv over dr. We're going to use the product rule. Okay, the product rule states the f dash of g plus g dash of f. Okay, so basically we have our first function. Okay, we call that f, and we have our second function, which is square root of 400 minus r squared. That's g. So basically the derivative of the first function multiplied by the second function multiplied by the derivative of the second function multiplied by the first function. Okay. So the derivative of the first function, which is 1/3 of pi r squared, that equals to 2 pi r over 3. We're going to multiply that by square root of 400 minus r squared. Sorry. I'm going to add that on to f. So f is 1/3 of pi r squared multiplied by the derivative of g, which is square root of 400 minus r squared. We can rewrite square root of 400 minus r squared as 400 minus r squared to the power of 0.5. We can use the chain rule. Okay, so the derivative of the inner function multiplied by the derivative of the outer function, and then multiplied by the inner function. Okay, that basically becomes 0.5 multiplied by 400 minus r squared, negative 0.5 multiplied by 2r. Okay, the 2r come from the inner function. Okay, the derivative of the inner function. Okay, that's where we get, not 2r, it's negative 2r. So we multiply that by 0.5 multiplied by 400 minus r squared to the power of negative 0.5 multiplied by negative 2r. So our next step is, so you know that 400 minus r squared, 400 minus r squared to the power of negative 0.5, that can be rewritten as 1 over square root of 400 minus r squared. That can be rewritten as square root of 1 over square root of 400 minus r squared. So just hold up. Square root -2 so basically that will become dv over dr equals to 2 pi r over 3. That becomes 400 minus r squared plus 1/3 of pi r squared multiplied by 0.5, and that can be rewritten as 1 over 400 minus r squared, but square root of that, of the denominator, multiplied by negative 2r. So now if we rewrite this, dv over dr equals to 2 pi r, 2 pi r over 3 multiplied by 400 minus r squared plus 1 over 3 pi r squared times of 0.5 times negative 2r over square root of 400 minus r squared. We can simplify this a bit more. Okay, so dv over dr equals to 2 pi r over 3 times of 400 minus r squared. 0.5 times of negative 2r is negative r. That just becomes plus of 1 over 3 pi r squared multiplied by negative r. And that just becomes negative, and you add 1 to the power of the r. And that's divided by 400 minus r squared square root. Okay, so you know that when as at the maximum, the gradient is 0. Okay, so therefore 0 equals to 2 pi r over 3 multiplied by 400 minus r squared minus 1/3 of pi r cubed. If I move the square root of 400 minus r squared to the other side, 0 times anything is still 0, so therefore we can just remove that entirely. Okay. Alright, so now we can rearrange this equation a little bit. Okay, so we say 1/3 of pi r cubed is equal to 2 pi r over 3 multiplied by 400 minus r squared. We can Alright, so 1/3 of pi r cubed equals to 2 pi r multiplied by 400 minus r squared over 3. Alright, that simplifies to 800 pi r minus 2 pi r cubed over 3. So 1/3 of pi r3 equals to 800 pi r minus 2 pi r cubed over 3. You move the 3 to the other side, so therefore pi r3 equals to 800 pi r minus 2 pi r cubed. If I move the 2 pi r cubed to the other side, so that'll become 3 pi r cubed equals to 800 pi r. So we're going to get rid of 1 pi and 1 r, divide both sides by pi r. So 3 r squared equals to 800. Alright. 3 r squared equals to 800, and therefore r equals to 800 divided by 3 square root. Okay. If you plug that into your calculator, so 800 divided by 3 and square root of answer, that actually gives you r equals to 16.33 centimeters. But we're not quite done yet, because we need to find the maximum volume. Okay, so find the maximum volume, you simply substitute 16.33 into your equation. Okay, so basically your equation was dv, not dv, it's v. So basically v equals to 1/3 of pi r squared. So r is 16.33, so 16.33 squared times of 16.33 squared multiplied by square root of 400 minus r squared, which is 16.33 squared. You plug this into a calculator. Be careful of the brackets, to put the brackets in the correct place. Okay, just to be careful, you don't want to make a mistake. So multiply by, sorry, I should do this first. 400 minus, should get your answer as you get your answer as V equals 3,225 centimeters cubed. Okay, that's what you should be getting your answer as. So let me just double check that. Time 16. Square root of answer times pi times yeah, it's actually 3224.5, but I rounded it up to 3225 centimeters cubed. So that should be your final answer, and getting this, your final answer should get your excellence grade. To get a merit grade, you're looking at correct expression for dv over dh. So dv over dh is correct. Dv over dh. Or dv over dr. Sorry. So or dv over dr. So if you get up to this step, you'll get a merit grade. To get an achieved grade, you're sorry, not merit. To get an achieved grade, it's basically just one mistake in the derivative. So basically the exact same thing as merit, but making one mistake. Alright, thank you for watching. I'm going to split this up into 3 different parts. Okay, so thank you for watching part 1. Sorry about the multiple cutoffs during the video, and sorry about being a bit clumsy here and there during the video. I promise it won't happen again in the next part, okay? Thanks for watching the video. I hope to see you all in the next one. Thank you. Bye.